Good afternoon and welcome everyone. My name is Steve Cronin and I am the Vice President and co-founder of Patriot Emerging Technologies and your host for today's webinar. We are very excited to be hosting this educational webinar and very appreciative that you are taking the time to join us considering the incredibly fluid nature of this pandemic. Our discussion today is specifically tailored to address a critical challenge faced by businesses, higher education, engineering firms, general contractors, and developers. And we're very fortunate to have a representative from a proven and experienced industry leader with us to help us walk through the topic, our topic, I should say, demystifying the deployment of EV chargers in New England. First, I'd like to introduce our speakers today. I am again Steve Cronin with Patriot Emerging Technologies, and I am here with my partner, Bill Bachoven, President and co-founder of Patriot. Very excited to introduce our featured guest speaker, Jared Carson from Enel X. Jared is an account executive at Enel X with broad experience in the clean and renewable energy space, working for environmental nonprofits, solar solution providers, for Bloom Energy, and for Enel X. Our agenda this afternoon will proceed as follows. I will be setting the table for our webinar discussing how the future is electric and why Patriot chose to partner with Enel X. I'll then be passing the ball to Jared from Enel X to walk through their EV charging solutions and how to acquire them. We'll then segue to my partner at Patriot, Bill, to discuss incentives where they exist, EV charging mandates in certain areas like Boston, installation timeline, and where Patriot can fit into this process. I'll then lead 15 minutes of Q&A, and we will conclude no later than 3:30. Before I proceed, though, I wanted to take a few minutes for some housekeeping items. As stated, we'll have a Q&A for about 15 minutes, depending upon the quantity of questions. Please type them in at the bottom. There's a button which allows you to enter a question. I'll aggregate and then pose to Bill or Jared, but if we run out of time, all unanswered questions will be captured, answered, and then distributed to this group. Please feel free to reach out to Bill or me with questions, comments, or if what we're about to discuss is something that resonates and might make sense to evaluate at your facility, and our contact info is on the right as you can see. Also, I'm based in Virginia. It's about 95 degrees outside. Bill has some storms coming through his area. And Jared is normally based in San Francisco, but is in Idaho. And as sometimes is the case working from home, technical issues can happen. But if we have issues to the point that the webinar happens to cut off, caused by the weather or otherwise, we'll send a note to all with a reschedule. To begin, I just wanted to provide some quick context for any that are unaware of who Patriot is. Patriot Emerging Technologies is a clean and renewable microgrid solution provider, and we help customers generate power on site that's cheaper, cleaner, and more reliable than the grid. And for over 2 decades, Bill and I have helped to deliver over 160 megawatts of projects across 300 sites, including more than 75 microgrids, to Fortune 1000 mid-sized companies, higher education institutions such as Home Depot, Partners Healthcare, Connecticut College, Cox Enterprises, and more. So why would someone engage Patriot? What special value do we provide? There's really no getting around the fact that on-site distributed energy resources can be complicated. How they work, do they work? How do you evaluate and how do you acquire? And Patriot's taking our almost 50 years of combined experience working for manufacturers on mission critical power solutions and clean and distributed energy solutions to help customers quantify and evaluate which of the 5 most innovative, impactful, and proven behind the meter solutions make sense, and help to translate and navigate this process to understand which solutions best align with their goals and priorities. So with that context of who Patriot is, and as a stepping point for the webinar content, I'm going to discuss for a moment the inevitable slope, which is getting steeper by the day, towards widespread adoption of EV charging. At this point in 2020, there's almost unified consensus of the projected growth of electric vehicles. In 2007, for example, there were just under 600,000 EVs on the road. and there are 300% that quantity, almost 1.8 million in 2020. This explosive growth is projected to increase, with 10% of new car sales to be EV in 5 years. And in 10 years, there are projected to be over 26 million EVs on the road. This growth has and will continue to be driven by a number of factors, but the price of lithium-ion batteries dropping by 87% in the last 10 years is a big one, making these cars much more accessible to the general public. Although choice and versatility was originally a big limiting factor to growth, in 2020, there will be over 100 electric vehicle options to choose from. The commercial shift to EV is also accelerating, helped along by the need to accommodate anticipated package delivery doubling by 2026. UPS, Amazon, and FedEx are purchasing EV trucks. They're investing in commercial EV startups with the thought that it's going to help them substantially move the needle on their sustainability goals, to demonstrate their innovation and responsible leadership, and enable them to capture incentive dollars that are available now that will help them mitigate the cost of this investment. This movement, this inevitable movement to electrification of vehicles, is certainly being helped along by a ban by a growing number of countries of diesel, and by countries establishing zero emission mandates and targets. But this shift has also made Tesla the largest car manufacturer in the world by market value, and many traditional manufacturers are heavily investing in EV to either enter this market or broaden their existing offer to carve off market share from Tesla and capture their share of this growing market. This competition ultimately is going to help the consumer, as it's leading to exponentially increased EV options and more attractive price points, which is going to continue to drive and accelerate overall growth of this segment. As consumer and commercial EV selection increase, price points are lowering from competition, and raw materials, the costs are dropping. There are also billions of program dollars available now to support the necessary EV infrastructure. Bill's going to talk about this in a minute, but there are utility, state, local, and federal funds in place and on the way to support this build out, this necessary build out of EV infrastructure. These can provide financial incentives to reduce costs to make a facility ready to receive EV charging equipment, the charging equipment itself, and the installation of the EV infrastructure. To be crystal clear, this shift to electrification at this point is not maybe it's going to happen. It's deeply in process now, and it's helped, as I said earlier, by mandates and regulations that will push this or pull it along. Over 10 states have new building construction codes for EV charging equipment, including Massachusetts, which Bill's going to touch on in a minute in more detail. And 12 states now have target regulations mandating a certain percentage of new vehicles to be EVs by 2025. One example is California, where the state's mandating 250,000 publicly available EV charging stations to be available in 5 years, and 6% of parking spaces need to be EV capable in new non-residential building. This is going to echo the Massachusetts mandate that Bill will discuss. But what this means is, whether there are existing regulations or mandates in place, there is the likelihood this will be coming, especially in the Northeast. And these regulations are going to impact the way you upgrade or build your parking facilities. So when Bill and I started Patriot, our core focus was clean and renewable microgrid solutions using innovative and yet proven technologies, really focused on DG and storage, distributed generation and storage. But we incorporated EV charging into our portfolio of solutions because, one, the size, the scope, and the acceleration of this shift in the electrification of cars and trucks over the next decade. These new mandates that I just referenced in different states and even cities, providing a patchwork of regulations to understand and comply with, and we can help to provide guidance and clarity. And third, the fact is, this shift is going to enable the need for cost-effective on-site or renewable generation solutions, which really is the rest of our solutions portfolio. So we decided to partner exclusively with Enel X for a number of critical reasons that I will now share. As you can see on the slide, Enel X is currently ranked the #2 EV charging vendor in the world, with over 80,000 charging stations globally and over 13 million completed charging sessions. They provide turnkey design, permitting, and installation. They have the highest value to cost rating, and their software JuiceNet provides the greenest charging. A critical point to me, actually a critical point, and this is to me was the most important point, is that for customers that are considering their EV charging options, they are part of and they are backed by Enel Group, an $84 billion enterprise company. Electric vehicles and the infrastructure to support has emerged, and it's out of its infancy, but it's far from a mature and established market. As this market grows, market shares will shift, competition will increase, and some companies who have started up or will start up may or may not be profitable, but they could struggle to survive this next critical stage of growth in this space. Enel X is part of the larger $84 billion Enel Group, one of the largest electric utilities and renewable energy producers, and is one of the rare providers whose core business is to sell EV infrastructure. So there are many impressive stats listed here that contributed to our decision, but as you can see, they're number 78 in the Fortune list with 65,000 employees in 31 countries. They're the #1 renewable operator in the world with 46 megawatts of managed capacity. But the net to us at Patriot is, with our combined 50 years of experience in the energy space, Enel X is not just an innovative company providing the best charging solutions and software for customers. Enel is an incredibly stable company providing peace of mind to customers that Enel and Enel X are in it for the long haul, and that the company will not just be around, they will be thriving in 10, 15, 20 plus years. So with that, I'm going to transition to Jared Carson at Enel X.
Okay, thanks, Steve. I'll start the screen share here. I appreciate that overview, and I think as I get this set up, one of the things I'll mention is we are extremely excited to partner on our end with Patriot Emerging. And I think as we see this electrification, EV adoption increase, there's going to be a need for folks like Patriot to understand the implications of that on electrical load, the economic implications, technical implications. And so, we see a nice home in your solution set where you provide, DG and backup power, where we're on the other end, maybe increasing some of that on-site electrical load. So very happy to be a part of your sort of solution set here and to be a part of this presentation today. Thanks for that overview. And again, thanks for everyone else for attending. My name is Jared Carson. I work as an account manager supporting Enel X's commercial and fleet customers, helping to install electric vehicle charging stations. And as Steve alluded to, the widespread electric vehicle adoption is coming. It also has many positive impacts around things like reducing domestic oil consumption and reducing greenhouse gas emissions. But one of the biggest barriers to adoption right now is the general lack of available EV charging infrastructure for those electric vehicles to plug into. And so while Steve's content and Bill's later on addresses sort of the overall market landscape, as well as maybe specific sources of utility funding that are available to folks to install EV charging, or folks that are called site hosts in the eyes of the utility. My slides will focus on the types of technologies specifically that are available to facility owners, or those site hosts, as I mentioned. There's various different ways as well that those site hosts can purchase electric vehicle charging stations. So we'll discuss a little bit of that. And remember, as we go through this, that EV charging stations can really be installed, I should say, although they're very similar to gas stations, or could be regarded similar to gas stations, they can be installed in areas where gas stations cannot. So at your home, at work, destination locations. So there's a tremendous opportunity available to folks like yourself who can demonstrate thought leadership while taking advantage of public funding to install EV charging stations at a low price point. Let's actually speak a little bit more towards this here and look at more of the product line before talking about some in particular. So when facility owners or site hosts are selecting an EV charger type, there's a few considerations. So what type of charging station? Do you want a network or standalone charging station? So we might refer to that as a smart charger or a dumb charger. Do you want to require payment to access the station, or is it otherwise provided, electricity provided as an amenity? Is the station publicly available all the time? Also, just as important, what's your budget? So for the most part, regardless of how you might answer those questions, the spectrum of charges you have to choose from is right in front of you. We'll dig into those considerations as well later in the webinar. So specific to the product line in front of you, on the far left are both of Enel X's residential and commercial AC, alternating current or level 2 charging stations. On the very far left here, for this left 2, you'll see what they're configured in what's called a wall mount configuration. Directly next to that are the same stations shown on 2 different types of stands. So one is called a pedestal, the other is just a basic stand, kind of just a sheet metal fabric itself. The big benefit of a pedestal might be things like the cable management system that you see on the juice pedestal there on the left, as well as an ability to integrate a universal payment terminal. So the ability to swipe a credit card and actually pay for power. On the far right, the sort of bigger unit with fast charging labeled on the top, that's Enel X's DC fast charger. You'll commonly hear that called DCFC as well. DCFC uses 3-phase, 480 volt electric circuit and delivers DC power, direct current to the vehicle. We'll go into both of these technology types, level 2, DC fast charger, in more detail on further slides. The first will be a focus on that level 2 product that I just mentioned. These are some of the easiest, most cost-effective and smartest ways to charge your EV. They're compatible with all electric vehicles and equipped with smart charging. So these level 2 stations can be installed either indoors or outdoors and typically charge a depleted electric vehicle battery in somewhere between 8 or 12 hours, depending on the exact specification. And so to that point, Enel X offers a 32 amp, 40 amp, 48, and 80 amp level 2 charging station. It's worth noting that most EV sedans on the market today can't accept a charge from an EV charging station any faster than a 40 amp. So when you're installing EV charging stations, one of the considerations is going to be the community of EV drivers that are plugging in there, the types of EVs that are charging, and whether or not simply they can accept the rate of charge coming from one of these stations. In addition to the amperage rating, another consideration, one that I mentioned before, might be connectivity. Very simply, are these smart chargers, can they connect to the internet? Those, quote, smart charging capabilities provide you with features like electrical load balancing or station access control, where you can either allow or disallow specific drivers from being able to plug in and use the station. Smart chargers also provide reporting capabilities, which is both a requirement for utility rebate funding and useful where customers want to calculate things like greenhouse gas reduction metrics. So by the way, if you're going to install a smart charger, you have to think through exactly how will you do that? How are you going to get that connectivity? As an example, Enel X provides stations that connect to Wi-Fi, which is meaningfully cheaper than stations that require an LTE or cellular data connection. Wi-Fi, again, as an example, is necessary in underground parking scenarios, but it also requires increased labor to install, which might not be ideal in scenarios where municipalities require things like union contractors, and those union contractors have union contractor labor rates. So thinking about installing, or when thinking about installing EV charging stations, it's important that you work with a company who has experience in all types of those scenarios mentioned before, and so that you can consider the impact of those different variables. Let's look through some of the flexible mounting stations that I mentioned earlier. Those same AC level 2 charging stations we just discussed can also be installed on stands where there aren't any available walls to mount them on. So key considerations on selecting the right stand type include whether or not you want cable management, as mentioned before. That's shown on the left with our juice pedestal product as an example. On the right-hand side where you have a juice stand, you're kind of just counting on your EV drivers, your community, to be good stewards of the parking space and hanging up that cord on the hook there. Otherwise, you might have folks who just leave it dangling or on the floor when they walk away, maybe not ideal. So how well do you know your EV driving community, and what type of environment are you installing this charging station in are definitely key considerations. Also outside of cost, I know I mentioned budget before as well. So just the simple juice stand on the right will cost even less than half as much on the pedestal on the right. All these are important factors when you're making a decision. One key consideration that I think is unique actually to this product, something you'll certainly see elsewhere in the market as well, is if you look at the juice pedestal here, you can actually see that the juice box, the level 2 station itself, the charger, is actually installed external to the pedestal. And the reason that's potentially important, as battery capacity now is limited, for the most part, there are some Tesla models that can accept a 48 amp charge. So I don't want to say that is for all EVs, but for the most part, sedan EVs now can't accept a charge faster than 40 amps. Well, what if that increases? You install a station and in 5-10 years you want to upgrade. The external installation of the level 2 station enables that seamless install down the line when battery capacity increases. By the way, if these stations look familiar, I'm going to show this case study here in a little bit. That's because they're the ones on the left, the juice pedestal installed at Gillette Stadium, where Enel X is the EV charging partner for the Patriots. And let's talk a little bit about the DC fast charger. So this product, this is called the juice pump for Enel X. This is, as mentioned, commonly referred to as DC-FC. These charging stations are those that require upwards of 25 kilowatts of power. When you're installing DC-FC, there are many of the same considerations compared to level 2 with respect to connectivity or smart charging. So where these stations might differ from level 2 is mainly around the amount of time it takes for them to charge a depleted EV, electric vehicle. So these will charge an EV in anywhere between 30 or 60 minutes compared to the 8 to 12 hours I mentioned before. In certain scenarios, you're going to hear the superchargers that are out there. They're few and far between, but the technology exists, although extremely expensive, to charge vehicles in closer to 15 minutes. Because DC-FC charges vehicles so quickly, you typically associate them with public charging. And when I say public charging, I mean available to the general public 24/7. Most maybe like a gas station where anyone and everyone can come up, swipe their credit card and pay. Now, because anyone who owns that parking lot or a parking lot, as I mentioned, can install EV charging, different than a gas station. But you're going to find these mostly in open air shopping centers, like those that have Walmarts, Targets, convenience stores, really any retail business who benefits from increased store traffic generated by providing EV drivers both a place to charge, but also 30 or 60 minutes to kill. So whether it's a bite of food or running into Target to get some quick groceries, all of those types of retail environments, brick and mortar locations benefit from that increased foot traffic or customer acquisition as a result of installing DC-FC in particular. So it's a bit of foreshadowing as well. Keep in mind the public charging scenario. This also influences the purchase options that are available to site hosts, folks who own parking lots, and we'll discuss that in just a few minutes. So as mentioned, connectivity, networking, depending on how you define it, but the ability for those smart chargers to connect to the internet is the same for both DC-FC and level 2. This is a topic, by the way, that Enel X is particularly interested in. We're an electric utility ourselves at our core, as Steve mentioned. So software connectivity allows EV charging devices to communicate with the electric grid. So on the other side of the meter, on the customer side of the meter, that software allows for site hosts to do things like, as mentioned, generate revenue for charging stations, They can also help to reduce energy costs. They can help with monitoring the EV charging station usage and more. Calling from the previously mentioned case study, Gillette Stadium in particular is leveraging this UseNet software platform to manage utility costs through controls that modulate charging during peak hours and keep their utility consumption and demand charges low. Enel fleet customers separately, they use our reporting functionality to track the amount of kilowatt hours consumed and therefore being able to calculate gallons of gas displaced for greenhouse gas reduction accounting. So where sustainability initiatives are the driver for a client to consider EV driving or EV chargers being plugged in, this type of functionality, specifically smart charging as well as reporting, can be very, very important in terms of making a decision. And again, a key driver influencing whether or not that client at all even installs EV charging stations. As an overview to some of the concepts just mentioned, in terms of the key question of, do I connect my charging station or do I not? Do I just put a piece of hardware on the wall that's basically a widget or a plug that dispenses electricity, or do I connect that widget to the internet and make it smart? There are several benefits in terms of that networked or smart charging station summarized here. The first, I think I alluded to it earlier, I want to emphasize it here on this slide. Incentive programs, so the rebates that Bill will overview here in a little bit, they require smart chargers specifically. The ability to capture data and understand by each charger how much it's being used, how many kilowatt hours are being deployed. So an absolute requirement to get those rebate dollars, which, as Bill will overview in a second, can be meaningful relative to the project cost. They also provide functionality like a control dashboard. So tracking consumption, as mentioned, allowing or disallowing specific drivers to plug in. Another example might be, and I'll speak more towards this later on when we go through the purchase options, but do I want the ability to, say, charge a specific, when I say charge, I guess I mean the monetary charge, not electricity charge, but do I want to charge a certain driver more or less than others? So some of our higher education customers, as an example, say, we want our professors to be able to charge at a lower rate per power than our students. However you want to define it, totally up to you, but having the smart charging capabilities allows you that functionality. So in terms of the incentive funding itself, Bill will go over more of the specifics on quantity and how they're structured, but I want to give you a little bit of an overview of just the ecosystem surrounding those rebates, how actually those funds work. So manufacturers like ourselves, EV charging manufacturers specifically, we're responsible for creating both the hardware and software solution that meets our utilities requirement for funding. So they typically have an approved vendor list. Unless you're on that list, they won't give you money to install EV charging stations. So important to reference that for each utility. The process of being approved typically involves stringent hardware and software testing before approval. So they'll go through live demos. Enel X has a utilities team that works specifically with their utility customers, but we go through live demos of the software, reporting functionality, all before we can be approved and a part of that program. Once the station is approved, site hosts who are connected to utilities with those programs, they can install the EV charging approved station, and again, they'll have some portion of their cost reimbursed. But what's important to note is that utility programs can be valued and structured differently, not just utility to utility, but even state to state. So certain utilities that go across state lines actually have different funding structures in place as soon as you cross the border, which could be potentially unique depending on where exactly a facility is located. So state to state, year to year, those funds and programs do change. They also go very quickly. And typically what you see happen is there's a few months once these program rounds open where you go to the utility website, you see there's millions of dollars in the fund, and folks say, great, I got plenty of time here because it looks like the utility is giving me funding that'll certainly last for the next few years. And then once someone catches word of the program and takes the funding, that number gets a little bit lower and folks start to move a little bit more quickly to capture those funds. And once they begin to be allocated towards projects, at that point, they do typically move fairly quickly. So it's important when those programs open up, you do the necessary steps to get yourself in line to receive that funding. Might include things like a site walk and evaluating your specific site for the ability to install charging stations, as well as what additional utility or electric capacity might be needed at that site to go ahead and install EV charging stations. Excuse me, thanks for letting me get a sip of water there, guys. So in terms of this slide itself, very important to understand the different purchase models that are available to you as a site host. Bill will explain later on the structure of EV charging programs, rebate programs, and the portion of costs that are reimbursed by the utility. Depending on the availability of the rebate program, its value and structure, as well as the EV charging hardware you're looking to install. You might consider any of these three options in front of you in order to purchase those electric vehicle charging stations. And I'll go over each sort of one by one here. We'll start on the left. This is a very simple capital expenditure, or just cash purchase of the station. So the site host, our customer, will own the EV charging hardware. They'll also be licensed the software that I mentioned before. They have complete control at that point over how to charge, if they don't want to charge EV drivers who plug in, the amount that they charge folks. So option one gives the site host the most flexibility over how they manage the software and software controls. The owner of the hardware also directly captures any available rebate funding, but also the 30% federal tax credit. So if you guys are familiar with solar, I think fuel cells as well also had a similar tax credit program. Electric vehicle charging stations have a 30% federal tax credit. It's equal to 30% of the net cost between the total cost of the project minus the utility rebate, where that rebate program exists. So our typical customer who buys cash, they're usually resellers, they're general contractors, multi-unit housing operators, and higher education customers. Again, because it provides that flexibility over the software control, how much you charge, don't charge, folks who plug in, those customers in particular typically have like a known EV driver community. Joe Schmo at 12 p.m. on Friday isn't coming to charge at their station. It's a known driving community, comes in certain hours of the day to charge and then leave. So this cash purchase is sort of the best option in those scenarios. So it's the second option. This is called an equipment lease. It's in the middle, also referred to as an as-a-service offering. These leases typically have 3 to 5 year terms. The site host will pay the EV charging solution quarterly. This payment will also include not just the hardware software, but operations and maintenance of that station and by the EV charging operator, whoever that may be. So customers who typically opt in for an equipment lease like this, they're usually our workplace or corporate clients. The third option, let me make sure I see our three faces, but I imagine you guys can see the screen. Steve, you can confirm on the far right, the finance option. Great, thank you. So on the far right, this option is sort of a purchase vehicle that's gaining in popularity in the market now. It is most popular really in retail and fleet environments, as mentioned before, or segments where, again, parking is sort of offered to the general public. I know I mentioned Walmart and Target. This third option on the right is typically the one used in those types of scenarios. It's also mostly used for DC fast charging, although in fleet scenarios in particular, sometimes you'll see it applied to level 2. What's important to note about this third option, there is no flexibility over the rate EV drivers are charged for power on the part of the site host. The person who decides the rate per kilowatt hour to charge those EV drivers, that's the EV charging operator themselves. This offering is only available in markets where there are rebates, in addition to the 24/7 public access, as I mentioned. This third option, called a financed or land lease option, depending on who you're talking to, in it, an EV charging operator is going to sign typically a 10-year plus arrangement to lease parking space from that site host. The site host, who will own the parking area, pays nothing and allows for the EV charging operator to recoup their initial cost of investment to install the stations by collecting both rebate money and then, as I mentioned before, recouping any of the money paid by EV drivers when they plug in. What is also interesting to note with this third option is that the electric bill, or a separate utility account, I should say, is tied directly to the EV charging operator. So the site host won't see any increased electric bill themselves. The EV charging operator is going to own and manage the relationship with the utility specific to any electricity that goes into EVs who plug in there. So if you're a site host and you go with this finance option on the third end, you're going to benefit from increased foot traffic from EV drivers plugged in looking for a charge. You might also benefit, given that in certain municipalities, there are requirements around installing a certain percentage of EV charging stations in new parking lots. This approach, the financed option, can be used to meet those regulatory guidelines while minimizing costs. So I appreciate you guys letting me speak here for this part of the presentation. I'm going to stop the screen share and let Bill talk about some of the specific structures of rebate programs relevant to certain markets in New England.
All right, thanks very much, Jared. Bill Bachhoven here from Patriot Emerging Tech. Thanks for having me on today. I'm going to spend a little bit of time talking about electric vehicle incentive programs and installation, and a couple of distributed energy solutions that complement EV charging as well. The state of Massachusetts has tremendous incentive programs for EV charging. It's no secret they are extremely aggressive in their clean energy goals and their electric vehicle goals. The first part of the programs, or one program, is with the utilities. Eversource and National Grid will both pay 100% of the make-ready costs for your charging stations. So getting the power to your facility, the trenching, the transformer, the service meter, wiring, conduits for your EV charging strategy, as long as you apply and get approval, 100% of those costs are paid for by the utilities. Eversource is out of funding for 2020, but accepting applications for next year, and National Grid still has funding for this year and next year as well. They will also complement the state in paying up to 100% of the cost of the charging stations and installation in certain areas, like environmental justice areas as well. So they're part of the program. The other side is the state of Massachusetts. The DEP has an EV incentive program that is extremely strong. For workplace environments, they'll pay 60% of the cost of a level 2 charging station. The space has to be designated as electric vehicle only, so parking space. But that includes the equipment and the installation costs, up to $50,000 per street address. The public option, meaning anybody can park there, they'll pay up to 80% of the cost of the level 2 charging station, up to $6,250 per port, and then $50,000 again per street address. Now, the city of Boston also has pretty major carbon neutrality goals, and a big portion of their greenhouse gas emissions, are due to transportation. So they have a requirement now that says that 25% of all new parking spaces must have level 2 EV charging stations installed. They don't have to be EV only spaces, but 25% of any group of new spaces have to be equipped with EV charging stations, and then 75% have to be EV ready, meaning the raceways and adequate space in the electrical panel and sufficient space within the electrical room has to be met for permitting. Now, one of the strategies that we've uncovered to help customers deploy systems is to use a DC fast charge, because the DC fast charge solution allows for 8 points, where a level 2 charging station gives you 1 point in their process. So, for example, a customer that is building a new parking garage and they've got to put 40 new level 2 charging spaces in, they could use 5 DC fast charge solutions and meet the requirements. So obviously what Jared just talked about was an end user customer that wants to deploy 5 DC fast charging solutions can go with the financed option, which means they don't pay anything. We just charge their drivers to charge their cars. So there's a real way that we can help you meet the requirements with the city of Boston and put some solutions in that help you with your sustainability goals at the same time. Next step is to talk about project timelines. So as you can hear from Jared, we've got an awful lot of experience helping customers first just understand what they're trying to do with EV charging stations. How are you going to use these? Who's going to charge? And how are the systems going to work? And how do we really leverage the software to make sure your demand charges don't spike? Now we can take you through the initial ballpark quote step. We do site walks. We help you apply for state incentives and utility make-ready services. We typically hear back from those folks in about 30 days. We can go to contract signature, and then it's just how much of the make-ready needs to happen. That could be as little as 30 days, or it could be as much as 90 days to install, depending on the make-ready requirements. But we can help you, obviously, with a turnkey design, installation, permitting, and all the way to commissioning, and hold your hand all the way through. So the construction process, we've kind of laid out what the process is here, from initial site design, utility design, permitting, all the way through construction planning, and turn on and installation, commissioning as well. Next step is to just kind of talk about a couple of distributed energy solutions that can complement EV charging that we've deployed with the enterprise customers. Obviously, electricity is the backbone of your buildings, your facilities, and your EV charging stations as well. We've seen tremendous outages just this past month with the storms that we've had in New England. I mean, 700,000 power outages just in the state of Connecticut, another 120,000 outages in Massachusetts. We saw hundreds of miles of down power lines. Over 1,000 transformers were in need of repair in Connecticut, and a couple thousand poles were down. So we saw tremendous destruction that required weeks of repair. And these storms, obviously, we seem to see a 100-year storm every couple of years now. They're more frequent, and they're just longer and more destructive. And obviously, we've got a transmission and distribution system that is above ground and very susceptible to elements. And time to power and capacity for adding new facilities can also be a challenge to end users. And we're seeing more and more customers in healthcare, in universities, retail, manufacturing turn to microgrids and on-site power generation solutions to help them with meet those challenges. Now at Patriot, Steve mentioned, for the past 25 years, we've been helping customers deploy mission critical power solutions like UPSs and generators, distributed power solutions like storage solutions and fuel cells and on-site power solutions. So we certainly can help you with a range of different solutions, from fuel cells to on-site solar, battery storage, and low emission combined heat and power solutions. Well, we thought we would take you through a couple of solutions today that we've seen grow in momentum the last 5 to 10 years. The first one is called a fuel cell, and it's a manufacturer called Bloom Energy that manufactures and delivers a solid oxide fuel cell. These systems sit right outside your building, and they're the most efficient systems in the world at turning natural gas or renewable fuel into electricity, and they do it 24/7 by 365. These guys are a public company. They're based in California. They've got manufacturing in California and Delaware. So it's a US-made product. And they've got a phenomenal list of Fortune 100 customers. About 25 of the Fortune 100 uses Bloom, and they'll tell you they get about 80% of their revenue from repeat orders, meaning a customer like Equinix or Partners Healthcare or Stop and Shop uses their product, has a good experience, and then keeps doing it over and over. The system itself, the fuel cell, is called an energy server. And the highlight of this is in the upper right of your screen, you can see one of these systems. It's made up of a refrigerator-sized power module that is 50 kilowatts in capacity. It's about 4 feet wide and 4.5 feet deep and about 7 feet high. And Bloom daisy chains these 50 kilowatt systems just in Lego block style to create 200 kilowatts, 300 kilowatts, up to 27 megawatts, I think, is their largest installation in Delaware, whatever size the customer needs to deploy. These systems are taking natural gas or renewable fuels and creating electricity without combustion. So there are no NOx, SOx, smogs emitted with the system, which means even in places like California, these guys are basically exempt from air permits. It's a very clean solution. The system can be deployed as a microgrid, so it can run when the utility is running. It can run when the utility is off, and that's very important to a lot of customers. It actually has helped customers in places like data centers to avoid buying UPS systems and generators and all of that stuff that you'd buy that requires a lot of capital and a lot of space and just sits and waits for power outages. A lot of these customers have deployed these systems and not had to buy that type of equipment. A lot of the customers that use Bloom Energy fuel cells don't actually buy the systems or buy the install or buy the service for the system over the term of the contract. They just pay for the power from the systems. You might have a utility like Duke Energy or the Southern Company purchase the system and just sell the power to the end customer. So that removes all the technology risk from that end user customer. And they're just buying power if power comes out of the box. So it's a very simple way to get started with this technology. The value proposition when it comes to new capacity, or whether it's EV charging or just adding another manufacturing line to your manufacturing facility, on-site power can happen from a capacity standpoint, in whatever size you need. A lot of times the grid, we've seen this in all over the East Coast, where sometimes the grid just can't get another megawatt to the site. The capacity doesn't exist. Sometimes it exists, and it just takes a couple of years to get capacity to the facility. So these solutions can be deployed in a matter of months and to the size that the customer requires. And once they're on site, they're extremely resilient and grid independent as well. The next slide kind of highlights that you can use natural gas as an input fuel. You can use renewable biogas, renewable hydrogen. In the next couple of years, Bloom just announced they'll actually be making hydrogen with an electrolyzer product out of water. So we'll take water and make hydrogen, and then use hydrogen as a renewable fuel for the fuel cell, which is really an exciting path where you've literally got mission critical power, always on, renewable in the future. So just to highlight a few customers in New England that are using this product, Stop and Shop tried a couple of systems about 3 years ago and actually found that the systems rode them through 15 power outages. I think it was in Westchester, New York, over the course of 3 years, and then went for a broader scale deployment of 40 stores in Massachusetts and Long Island. places where they're vulnerable to storms and outages. And these guys, their goal is to be the beacon of hope when a community loses power, and be there for the community to help them through in the toughest times. We've also seen Partners Healthcare with multiple systems, from powering their hospitals and critical care facilities to their primary data center, and then their beautiful new headquarters in Somerville, Massachusetts. Lastly, we've seen a 2 megawatt microgrid ready deployment at Gillette Stadium. And this is a picture of the Gillette Stadium install, 2 megawatt system. Next, we wanted to highlight enterprise storage as a solution as well to, what we've seen obviously in the last few years is as these lithium ion batteries have become cheaper and cheaper, we've reached an inflection point where companies can leverage artificial intelligence software to tell batteries when to charge and discharge, to charge batteries when power is inexpensive, and then discharge those batteries during peak power times to really save money for customers. And we've seen these systems grow in deployments over the last few years. The peak shaving and load shifting that these systems will do complements demand response assist programs as well in places like Massachusetts that have tremendous incentives for these, the enterprise storage products. We've partnered with a company called STEM that really has the largest enterprise storage network in the world. And that's really important because, as their system gets installed more and more times, their algorithm gets smarter and smarter at predicting how to shave peak load power. These guys have the largest install base we've seen, and have a product that is extremely robust and proven. And obviously, what we can do is help you all the way through from your goals and understanding how your buildings use electricity and what the shape of your load curve looks like, to looking at different distributed energy solutions and model them out from a financial standpoint and a technical standpoint, help you with sustainability impacts and federal and state incentives, all the way through to contract negotiation and project management. We'd love to help you with a solution that can provide a great return for you, depending on what your goals are. All right, I'm going to turn the mic back over to Steve for a quick question and answer session. Go ahead, Steve.
Thank you, Bill, and thank you, Jared. Nice job with both of your sections. So we've got some really good questions that came in, and I've aggregated them, and we're going to spend, again, just a couple of minutes on this. So the first question, Jared, you talked about how you can set up different, and you already covered this, but I think it would be good to reiterate how you can set up different rates for different types of customers using a charging station. For example, on a college campus, a professor would get one rate, a student another rate, and maybe just a general visitor would get another. How is that mechanism enabled based on the way the solution will be sold or procured by a customer?
Yeah, thanks, Steve. And so the maybe key component there, as I mentioned, there's the two separate scenarios. One is where the general public is coming, charging, swiping their credit card, and moving on, and that the ability to charge different rates is not relevant in that public charging case. Where it is relevant is in a private payment scenario. So in other words, every EV driver who could possibly plug into these stations is known by the software, and so we can actually upload specific classes of users or specific users and assign each of them a rate per kilowatt hour, rate for electricity within the software platform itself. And so that's what enables that mechanism. And when that driver goes and they take their app, they walk up to the station, there's a QR code on the station, and they scan the QR code. The software is going to recognize that EV driver as that specific user with that specific rate, and then charge them appropriately. For Enel X in particular, what we do is we have an onboarding process once the site is installed. So when the first when the stations first go in the ground, our client services team will onboard that site. Typically, there's a facilities contact, someone there who they'll partner with. get the information they need, and then set up those driver classes, as defined by the site host, by the customer.
That's great. Thank you for that additional level of detail on that. Bill, I have a three-part question for you. You stated as part of your presentation that part of the design strategy is used to ensure that demand charges don't spike. So the question is, does this mean that Enel X or Patriot will also install battery energy storage systems to mitigate those demand charges? That's the first question.
Yeah, I can take that. So yeah, absolutely. We'll try to understand your load, and energy storage is a great way to basically make sure that your demand charges stay low. And we've done that in the past, where we install a battery solution and a software solution to make sure and charge the batteries where energy is cheap and discharge where it's expensive, and really, peak shave and keep those demand charges down. The Bloom Energy servers too, from a distributed energy standpoint, also keep demand charges low. And with a lot of distributed energy solutions, you got to turn the system off to maintain the system and service it, and sometimes weeks at a time, multiple weeks per year. The thing that we like about the Bloom Energy server is, if I need to service that system, I can take one power module, that 50 kW power module, and turn it off, while the other systems, the other power modules, continue to power the load. So it's really the one distributed energy solution that can be deployed. You turn it on and it's going to stay on for the next 15, 20 years, and you're not going to see your demand charges spike when you service the system. So I hope that answered that question.
Yeah, and the follow-up, the next two questions are connected, and you'll see how in a second. So the second and third part are, how would these be incorporated into the financing model? And then those two options that you just discussed, so storage and fuel cells. And are there other revenues or programs, incentives, which could be recognized to offset those costs of those solutions to improve the ROI?
Yeah, no, that's a good question. So, and with so we've really talked about three different solutions: the electric vehicle charging stations, the battery storage solutions, and then fuel cells. Each of those solutions has basically energy as a service contracts available. So where the customer doesn't have to spend money up front, they can kind of pay as they go, and as they use the power, or they use the functionality of the equipment. So we've seen both. We've seen customers go with energy as a service contracts for each of these technologies at the same site independently. And we've seen contracts that have, for example, fuel cells and energy storage under the same contract, and performance guarantees and all that. It's on the same paper. And so it really depends on the customer and how we structure it.
Yeah, and the third part of that was similar to the incentives that are in place for EV chargers. Can you talk about some of those incentives that are available to kind of offset those costs, whether it's storage or fuel cells in the New England area?
Yeah. So our audience is New England based primarily. So yeah, absolutely. So we talked about the EV charging incentives. Massachusetts and Connecticut are two of the strongest states in the country when it comes to incentives for fuel cells. So Massachusetts has two incentives, really. The Alternative Portfolio Standard, APS, is a state incentive by the DOER has set up to allow end users that use fuel cell technology to sell RECs. The value can be anywhere from 2 to 3 cents a kilowatt hour. There's also an incentive by Eversource and National Grid called the Energy Efficiency Incentive, which is actually an upfront check, and they'll spend $500,000 for every megawatt that's installed, and literally write a check in year one. So not only for a lot of these customers, not only are they saving money without reaching into their pocket for capital, actually getting pretty good sized checks in year one from the utility to help because what you're doing is you're helping the utility make their clean energy targets. And then in Connecticut, it's probably the best fuel cell incentive in the country. The LREC incentive is a reverse auction where customers can take advantage of anywhere from 3 cents a kilowatt hour to 6 cents a kilowatt hour, generally, depending on what they bid into LREC. to offset the cost of the fuel cells. So it's a tremendous incentive. So yeah, New England's a great place for, for all of these technologies. I'll just add that on the storage side, Massachusetts is really strong for storage. The Massachusetts SMART program provides great incentives for battery storage technologies. And then the demand response programs are also very strong to encourage end users to have the batteries available for utilities when they have capacity challenges.
Thank you, Bill. I'm going to give you a break for a minute. And Jared, you're up. Can you answer the following question? What percentage of vehicles on the market cannot accept fast charging? Also, what car manufacturers can accept it, and how fast will this charge?
Yeah, so appreciate that question. I don't know the exact percentage. I think there's a few maybe different components to that. So the first thing to understand is that there are different ports connected to charging stations associated with level 2. One's associated with level 2, the other is associated with DCFC. And so there's some vernacular around what those ports are called. There are a bunch of letters and numbers. We don't need to go into that here, but just know that there are different ports associated. So the very first question is, am I buying an EV that has the type of port or can accept the port from a DC fast charger? Think of sort of the smaller, older EVs, like an e-Golf might be one, or the smart car is probably another good example of the types of EVs that don't accept DC fast charge, mostly because it's impractical. You just simply don't need it because the battery capacity is so tiny. So I think that's maybe the first consideration. The second then is, conceptually, one thing to understand is that the actual charger, we call it an EV charger, but the charger is kind of in the vehicle itself. The station, the EV charging station, provides the capacity. The voltage source, the electricity draw actually comes from the car. So that's one thing to note. So the vehicle type itself, the battery and battery capacity also influences whether or not that vehicle can accept the high rate of charge associated with the DCFC. Most of the new vehicles going on the market, so Tesla certainly included, all of the Tesla brands. You have the Porsche Taycan, you have Hyundai's coming out with a few different EV brands, Ford as well. All those types of vehicles will accept the DCFC. It's really just, again, the smaller electric vehicles and sort of the older brands that for the most part don't.
Gotcha. Okay. Thank you, Jared. Another question. Are you aware of any EV charging incentives in Connecticut, and would nonprofits be eligible for any state or utility incentives?
Yeah, so important to note, there are no current incentives in the state of Connecticut. The state legislation there is actively setting up their zero emission targets. So certainly over the next few years, we can expect rebate programs and funding to follow. What does that impact in terms of a project now, by the way? Maybe in that scenario, you don't need the smart charger unless you have that environmental driver I mentioned around reporting and calculating greenhouse gas emissions, something that's a key driver for the project. If the goal is just simply provide charging to a specific community, maybe you just go with the quote unquote dumb charger in that scenario, not pay the software fees, and go away with sort of a lower cost of install to just get the charging station in where there aren't any current incentives, or they're a few years out, which is the case in Connecticut in particular. In terms of nonprofits, they most likely, and I'm not a tax expert, so that'll be my very strong asterisk here, but they most likely do not qualify for the federal tax credit. But where they own a utility account and where there are rebates available, they will absolutely qualify for any utility funding. Again, if that nonprofit is in Connecticut, there just simply aren't any there. But if a nonprofit's in another state like Massachusetts and connected to National Grid or Eversource there, they would qualify for the utility rebates in that scenario.
Okay, that's great. Thank you, Jared. Final question. As it relates to rebates, so can you restate who applies for the rebates, the utility rebates? Who's responsible for that? Can you spend a minute on that?
Yeah, no problem. In nearly every scenario, it is the person who owns the utility account. They will be responsible for submitting the application. The EV charging provider or installer may be able to help with aspects of that, but the responsibility ultimately goes to the utility account holder to apply. There are very specific utilities in specific regions that do allow third parties to collect and apply for the rebate. So you really have to know who those folks are ahead of time. National Grid does happen to be one. So during the 2020 hardware rebate program round, which recently closed, but in that program round in particular, we were able, as an EV charging provider, to go apply for rebates on our customers' behalf, and we could show the benefit of that in our upfront project cost that we charge to our clients. So again, very specific scenarios, the third-party rebate goes to the EV charging or a third party, but broadly, the utility bill account holder will be the person responsible.
Okay, thank you. Thank you, Jared. And thank you both of you. That's the end of our questions. So at this point, I'd like to say from the three of us, thank you all for joining. Please reach out to us with any questions or comments that you may have. And good luck to all during this continued crisis. And we hope all of you, your families, and your staff stay healthy and safe. So this concludes the Patriot Emerging Technologies webinar, Demystifying the Deployment of Electric Vehicle Chargers in New England. Thank you.